Hello, everyone. We are back now, and we are going to start to talk about and dive into some histograms, looking at some statistical measures, and then probability, permutations, and lots of kind of fun examples that we'll build upon. So, before we get started and hop right into it, it's very, very useful, and we've kind of touched on this a little bit, but we really kind of, in order to quantify total uncertainty and error, we first need to understand kind of the key distinctions between sample and populations. So again, we are going to estimate a distribution of error and basically infer some characteristics about the population based on a sample that we take. So again, we have a distribution of error, and that's the probability that an error will occur. And then we're inferring information about a population from which a sample is drawn. And again, oftentimes, if I have a room and if I want to look at the temperature in the room, there are effectively an infinite, number of places I can take. I don't know the true population ever. If I have, pieces and samples, or if I have tons of aluminum, I don't know what the tensile strength is necessarily, but I'm going to about the full population because I cannot possibly measure that tensile strength across the whole population. So instead, I'm going to take a smaller sample size. So if I have, the big examples like a bag of marbles. So if I had an infinite, bag of marbles and I wanted to measure, from this population, what is the diameter of the marbles? I'm going to take, a sample, a smaller subset. So we can say that this n is number of, the population is effectively infinite. I'm going to take some n equals, 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Some sample of 7 and infer something and measure the diameter and infer something about that population. So that's kind of the key thing that we want to understand here. So we should approximate, again, the average of that population. So that's the goal. That's effectively what we are trying to do here. Now, we can actually, it's very fun to actually try and visualize this. And one of the key pieces of code that we are going to utilize in this course is going to be R. So our R program. And throughout our lectures, we are going to incorporate R to understand some of these concepts and also to solve a lot of questions. And you will hopefully, it's my, very strong suggestion that you, potentially utilize this for, your exams as well. So let's go ahead and right now, let's open R. So we're going to open up our R Studio, auto detect, do all of this good stuff. You can see behind the curtain to kind of understand what this population, all these things are. So yes, that's great. So this is the console. I want to open up a new script. So I'm going to do an R script here. Again, you can do, the classic print, Cal Poly Humboldt ENGR 322 class rocks. And I can do Shift Enter, and you can see it printed there. Yay, you can do the hello world. But anyways, let's get back to it. So first, I want to basically build a population. So I am going to randomly, I'm going to do a population of marbles. And I'm going to randomly, I'm going to take a random norm, and then I'm going to define essentially how, so you can see here, it automatically pops up. Sometimes you may have to read in certain libraries to get certain functions. And so actually, let's just kind of, while we're kind of starting this R journey together, let's go ahead and I'm going to, let's do help. You can see what is the function R norm. So you can see normal. So here you may have to, if it's not working for you, you may have to read in the library stats, and we can kind of come into the, actually, we can do, like library stats. And you can just Shift Enter that, and it reads in that library. You may have to even do install install packages, and then you can do stats. And you can install that here. I don't want to, no. Is in use and will not be installed. So see, I'm already using it. So I need my number of samples. So I'm going to say just like 5,000, large. I'm going to define my mean to be equal to, let's say 10 millimeters. And then I'm going to have my standard deviation of that population be equal to 1. And I can get that. And when you do that, you see these numbers. And I'm going to make it basically kind of just a list. So I'm just going to do the C, which basically concatenates it and basically shifts it down. And I could look at like the dimensions of my pop marble, and I can see. Actually, I can look at the length of pop marble, and it's 5,000. So now, what does it mean? And actually, let's look at what's the mean of my pop marble, and I can look at the mean, the actual mean of the population, which again we don't normally know. But I can do pop marb. And we can see that mean is about 10, as we would expect. The standard deviation of pop marb will be SD. And again, I'm just again assigning a variable. Standard deviation of pop marb, and we can see the same thing, about 1, which is great. So now I want to take a sample. So I want to kind of just randomly, I'm going to sample the system. So I'm going to say my first sample, which is just going to be one just random measurement. So I'm going to sample, and I'm going to sample my pop marb, my population, and I'm going to pick 1. And I'm going to pick it. And we can see that's not a good approximation, right? Like this is not 8. 8 is not really defining our system well at all. So what if I increase my sample size? So I'm going to do sample, and I'm going to do my pop marb, and I'm going to sample it and look like this. So let's do 5, and then let's look at the mean of 5, which is going to be my mean of S5. So my mean, that's getting better, right? What about, and let's just copy this here. I'm going to copy this here. Let's jump to 50. And then hopefully you'll see that this will get a lot better. I'm just doing Control Enter. That's getting a lot better. So as I'm increasing my sample size, I'm getting a better approximation of my system. So again, that's the kind of the whole idea. And again, we don't as professors or as researchers as well, we don't make you do experiments to be mean necessarily. It's more, again, we want to approximate the real system. And actually, we can do a histogram. Actually, we'll save that for later. But that's effectively the idea here. That's why we're doing it, and we're looking essentially at these histograms, and we're showing. My pen is somewhere else. And we visualize essentially our data in these histograms, and we'll learn how to plot those in a bit as well. So that is sample versus population. Next time we'll get into visualizing data, and then we'll move on and see you next time. Thanks. Bye.